I just wanted to give you a little bit more about carbocation rearrangements as well. Now, as I had said earlier, the tertiary carbocation is more stable than secondary, is more stable than primary. And we can see the tertiary is characterized by having 3 C's connected to the C+, the secondary 2 C's connected to the C+, and the primary just a 1 C connected to the C+. If we take another example, we've got this isobutyl type chloride here. And when we take the Cl off here, we end up with a primary C+. There's actually 2 possible ways that this primary C+ can rearrange. We can move the hydrogen over with its electrons, which will end up with the tertiary C+, or we could have the possibility of moving the methyl group over. But if we move the methyl group over, we have to move the methyl group and its electrons. And what that will give us is a secondary carbocation. So both of these would be possible rearrangements from a primary carbocation. Just realize that carbocations will rearrange to a more stable carbocation, but they will never rearrange to a less stable carbocation. So you'll never get an instance where a tertiary carbocation will rearrange to a secondary or a primary C+. So if we have this kind of situation with the primary C+ that can possibly rearrange into a tertiary or a secondary, then what happens is all 3 of those would end up being possible products if we use that as a guide. So let's take a look at that. So an example would be something like this. And we'll react it with the isobutyl chloride. And AlCl3. And what we're going to end up with as products would be the primary possibility, which is this one, and that would just be from taking the Cl off the CH2, putting a positive charge here, and that would be the product we'll get. Also though, we will get the tertiary product, and that comes from rearrangement by having this H shift over, just like we saw before. And we will also have the secondary possibility as well. So we'd end up with 3 possible products from this reaction. Alright, let me just reiterate where these different groups come from. So we've got our CH2 up to plus, we have our 2 CH3s over here. Move that over and we end up getting our tertiary C+, and the tertiary C+ is what leads to this product. There's your tertiary group right there, but adds to the aromatic ring. Adds in the same way as we saw before. If you want to look at that mechanism again, you can go back to the earlier mini lecture on the Friedel alkylation reactions. Alright, let's look at the secondary one. And what we're seeing is the whole methyl group move over, which gives us this secondary C+, and you can see that it's the addition of this carbocation that leads to the third product. Notice that the connection point to the aromatic ring will always be through the carbon that has the positive charge on it in each instance. So we've got this one where the positive charge is here, that will lead to this product. This one where the positive charge is on the tertiary carbon, that leads to this product. And here the positive charge is on the second carbon, and that's what leads to this product.